Okay, so yesterday we talked about 45, 45, 90 triangles. Today we're going to talk about 30, 60, 90 triangles. So at this point, we're in the second half of Unit 7. We'll have a test on October 1st and October 2nd. End of the 9 weeks is October 14th. So I think if I counted right, I only see everybody in person like 8 more times during the hybrid learning before the end of the 9 weeks. So something to consider, like make sure we're getting our stuff done during e-learning as well. Okay, so top part here, little warm-up. If we cut an equilateral triangle in half from the vertex, what can we definitively say about the resulting two triangles? So remember, the equilateral means that they're all the same. Okay, they're all the same length. All sides are the same. Okay, so what I want you to do is take a minute, pause the video, look at this example, and see if you can come up with, just like yesterday, the bullet points of what we can definitively say if we draw a triangle or if we cut it straight in half. All right, so take a moment, pause the video, and we'll talk about it in a second. Okay, so hopefully at this point you've paused the video and come back. So equilateral triangle, if you guys were in class, this would be fantastic because I would just be asking you. But in an equilateral triangle, we know all the sides are the same. So we also know all the angles were originally the same, right? So in an equilateral triangle, the triangle has to add up to 180. If they're all the same, then all of these angles would also be the same. They'd be 60 degrees. So if we cut it in half, then we know that this is 30 degrees, right? So it makes a 30, 60, 90 triangle. So the two, it makes two 30, 60, 90 triangles. Okay, and we also know that if these sides were, let's say, like a total of 1, right? Like let's say they were 1 unit long. Well, then now it would make it a half a unit, right? So the bottom, or the small side of the triangle, is half the hypotenuse. Okay, so look again. So when we cut it in half, that makes this the hypotenuse, and this is the bottom side, right? So now it's 1/2 because we cut it in half. It is 1/2 of the hypotenuse. Okay. Now also, if you look and see, you can see that the smallest side is directly across from the 30-degree angle as well. Okay, so if we draw a line here, okay, that would be the smallest side. So smallest side is across from 30-degree angle. So we could say that it kind of points at it, right? All right, that's all really relevant information because when you're working with the 30, 60, 90 triangle, it is another special right triangle. There are 2 of them, the 45, 45, 90, and 30, 60, 90. In the right triangle, where one angle is 30, the other non-right angle must be 60 degrees because that's what helps it add up to 180, so 30, 60, 90. In a 30, 60, 90 triangle, the shortest leg is opposite the 30-degree angle. So this is the shortest leg, right? So that means the medium leg, okay, is opposite, the long leg is opposite the 60-degree angle. Now we say long leg because this is a leg and this is a leg, right? This is the hypotenuse. This is not a leg. So leg, leg. Okay. So let's take a look at this chart just like we did yesterday. You're going to reduce your answer to the simplest radical form. We want to find what is the length of the missing leg. Well, what we already know is that this is across from the 30-degree angle, right? Okay, that's across from the 30-degree angle. So that tells us that this hypotenuse is double that. Okay, so if the short leg is 8, the length of the hypotenuse is 2 times 8, which is 16. Okay, so that's the length of the hypotenuse. So length of the missing leg, we don't know yet, but we'll figure that out. we can just use Pythag because it is a right triangle. So a squared is 8. We don't know what x is. And this is 16 squared. So 8 squared is 64. X squared. 16 times 16 is 256. Subtract 64. You get x squared equals what is that? 92, I think. Okay. Which you can split into, when we get our calculator, if you think about it, you can split into x equals 64, which we just took out of it, and 3. Okay, so square root of 64 is 8, so 8 radical 3. So there's our length of our leg. Now, this is the Pythagorean theorem as well, right? So in this case, that would be the same situation. All right, so moving on to the next triangle, you have 9 is the medium side. Okay, we don't know what this side is, and we don't know what the hypotenuse is. Well, we can't do much right now because we don't know what the small side, so we can't double it. So let's just go ahead and use Pythagorean theorem. And we know, but we do know that the hypotenuse is 2 times that, right? So let's use Pythagorean theorem, see if we can come up with this. So x squared plus 9 squared equals 2x, because it's double, squared. Or actually, I should say, yeah, that'll work. So x squared plus 9 squared equals 4x squared. When I subtract, I get 81 equals 3x squared. Divide by 3, 27 equals x squared. Okay, take the square root of that. Okay, and that is 9 and 3. Okay, 9 simplifies to 3, so this is 3 radical 3 is x. Okay, so that's this. 3 radical 3. So if this is double that, then this has to be 3 times 2 is 6. So this would be 6 radical 3. Okay, 6 radical 3. All right, moving on. Okay, this is across from the right angle. So now, as you can see, as we're moving along, in order to get the small side, it's just x. In order to get the medium side, okay, so where's it at? There's a theorem here. The length of the long, if the length of the short leg is x, the length of the long leg is x radical 3, and the length of the hypotenuse is always 2 times x. So we can figure it out very quickly just based off that information. So if I draw that right triangle again, okay, this one looks more like a 45-45, but we'll say it's a 30. Okay, so if my short leg is x, my hypotenuse is 2x, then my medium leg is x radical 3. Okay, so on this last one, if they give us the hypotenuse is 24, okay, also we know that this is the 30-degree angle, then across from that 30 is our shortest leg. Well, remember, our shortest leg is half of the hypotenuse, so if it's 24, our shortest leg is 12. Okay, so leg is 12. All right, and then we could use the Pythagorean theorem to find the third leg, and you should see, if we do it correctly, it should be 12 radical 3, because you multiply radical 3 by the shortest leg. So let's just act like this one's x for now, just to verify that it is going to be that way. So 12 squared plus x squared, equals 24 squared. 12 squared is 144. 24 squared, let's use our calculator, because I don't remember off the top of my head. 576. Okay, subtract 144. Okay, minus 144 equals 432. Okay, so again, if this is right, then when I take the square root, it's going to break up to radical 3 and something. All right, so what number times 3, or 432 divided by 3, gives you 144? Okay, which ironically is that, right? But it's not really a coincidence. Okay, so x equals Square root of 144 is 12. 12 radical 3. See how these match up? See how they match up? And the hypotenuse we already know is 24. Okay, so I want you to go through some practice problems. Try to do the same thing. Remember that if it's the short angle, if it's across from the short angle, that's the small leg. Okay? Then you have this hypotenuse is 2x, and then this would be x radical 3. Okay? If this is x. All right? So go through those practice problems first. Answers are at the bottom, and then you can go in the exit ticket. If you have any questions, let us know. Send us a Canvas message, or of course, if you're in class, we can help you there too. Have a great day, and I will see you either on Monday or Tuesday.